Hi everyone, welcome back to Deep Dive Daily. Today we are going on an absolutely epic journey across the cosmos to answer one, massive question.
So, what is the biggest star out there? Now, you might think that's a super simple question, right? But the answer? Oh, it is full of cosmic twists and turns. See, it's not just about finding the heaviest star, but the one that literally takes up the most space. So, buckle up because we are about to find out together. Let's get started.
All right, first stop on our cosmic tour, the wannabes. We're talking about the things that really want to be stars, but they just don't quite make the cut. Think of them as the almost famous celebrities of the universe.
Okay, so on one side you've got planets like our neighbor Jupiter. It's made of the same exact stuff as our sun, mostly hydrogen and helium, but it's just not massive enough to get that nuclear furnace going. Then you have these things called brown dwarfs, which the source material hilariously calls a huge disappointment to their moms. I mean, wow. They're way more massive than Jupiter, but here's the really weird part. Jamming more mass onto them just makes them denser, not actually bigger. They can kind of glow a little bit, but they are definitely not stars.
So let's leave those wannabes in the dust and move on to the real deal, main sequence stars. This is basically a star's long, stable adulthood. It's where they spend most of their lives just happily fusing hydrogen into helium and, shining bright.
Now for main sequence stars, there's a pretty simple rule, and it's that mass is everything. The more mass you have, the hotter you burn, the brighter you shine, and the faster you die. It's the ultimate live fast, die young story, but written across the cosmos.
And this table just illustrates that perfectly. You have these tiny little red dwarfs that will live for literally trillions of years. Then there's our sun, with a very respectable 10 billion year lifespan, and then you get to the massive blue stars. They burn so intensely that they're gone in like 20 million years. An entire generation of them can be born and die in the time it takes our sun to orbit the galaxy just once. Isn't that wild?
Okay, so it seems pretty simple, right? More mass equals a bigger star. But this is where our little cosmic journey takes a very, very unexpected turn.
So let's meet the heavyweight champion of mass, a star called R136A1. Just look at this chart. It has a completely mind-blowing 315 times the mass of our sun. It is an absolute monster.
So we found it, yeah? Case closed. The most massive star has to be the biggest star in the universe, right?
Nope, not even close. And this is the plot twist I was telling you about. Despite having 315 times the sun's mass, R136A1 is only about 30 times its size. So what on earth is going on? Where are the real giants hiding?
Well, it turns out to find the biggest stars, we can't look at them in the prime of their lives. No, the secret to becoming truly gigantic is all about how a star dies.
Okay, so it's basically a three-step process. First, the star starts running low on its main fuel, hydrogen. Then, its core contracts under all that gravity, getting insanely hot. And finally, all that extra heat from the crushed core blasts the star's outer layers outwards, puffing it up like a colossal cosmic balloon. And listen, this isn't some far-off abstract idea. This is literally the future for our own sun. In about 5 billion years, it's going to swell up to 200 times the size it is now and become a red giant, swallowing Mercury, Venus, and probably Earth. Yeah, kind of sobering, right?
So if we put everything we've just learned together, we finally arrive at our destination. We're looking for the most massive stars at the very end of their lives. Ladies and gentlemen, welcome to the land of the hypergiants. Now, these aren't your regular red giants. No, these are what happen when the most massive stars reach their final phase and swell to truly ridiculous proportions.
And here it is, our current champion, the king of all stars, Stephenson 218. It's a red hypergiant, and as of right now, it is the largest star we think we've ever found.
So just how big is it? Get ready for this. Its radius is estimated to be 2,150 times the radius of our sun. Just let that sink in for a second. It's almost impossible to even picture.
Let's try to put that into perspective. If you could travel at the speed of light, the fastest anything can possibly go, it would still take you almost 9 hours just to go around it one time.
Okay, how about something a little more down to earth? The fastest plane we've ever built? It would need 500 years to make a single trip around it. 500 years. Can you even wrap your head around that?
And here is the final,
Mind-shattering fact. If we just swapped our sun out for Stephenson 2-18, its surface would stretch all the way out past the orbit of Saturn. It would just swallow Earth, Mars, Jupiter, and Saturn whole.
But this giant's reign is temporary. It will end its life in a spectacular supernova explosion. And as the source material so beautifully puts it, it will be giving its gas back to the galaxy, starting the cycle of birth and death again. The raw material from this one star will go on to create whole new generations of stars and planets.
Wow, what an incredible journey. From failed stars all the way to the cosmic king, it just goes to show how wild and wonderful our universe really is. Hit that like button if you enjoyed this, share it around, and subscribe for more. Drop a comment below with your views and let us know what other cosmic mysteries we should explore next. See you tomorrow at the same time.